A 6 kg object is at rest on a frictionless horizontal force. If the object is moved from rest by the force, what's the velocity of the object at time t is per second? So we are going to find the answer of this question. So the mass is going to be 6 kg, and the momentum is going to be area of this diagram, and this is also equal to this equation. So we are going to find the area of this equation. So the area is gonna be this. This is gonna be rectangular, and this is gonna be sum of two triangle. So 36 is gonna be the momentum. We found the momentum, and we are going to apply this to this equation. So the velocity is gonna be 6 meters per second. How much meters will a 4 kg bird traverse if it starts from rest and fails freely for 3 seconds? So the mass is gonna be 4 kg, and initial velocity is gonna be 0 meter per second, and time is gonna be 3 seconds. And we are going to apply this equation. So 45 meters is gonna be the answer of this question. At T is 0, a ball is at rest at the top of a 20-meter inclined plane. Then the ball rolls down the plane with constant acceleration. If the ball rolls 2 meters in the first second, how far will it have rolled at T is 3 seconds? So this is the ball. And the initial velocity is gonna be this. So we are going to apply this equation. So 80 meter is gonna be the distance the ball rolled. A 90-kilogram object moves around a flat, circular track. The track has a radius of 20 meters and the object completes one revolution every 8 seconds. What's the speed of this object? So the mass is going to be 90 kilograms. The period is going to be 8 and this is the same with the frequency of 1 over 8. So in this case, what is going to be the velocity? So we are going to apply this equation. We are going to apply this equation. So the speed of this object is going to be 15.7 meters per second. A hydraulic ladder lifts a 100 Newton box to a height of 3 meters in 15 seconds. After the box is lifted, how much power is required to hold the box at that height for 60 seconds? Power is the rate at which work is done. Work is only done when a force causes an object to move some distance. If the box is being held in one position, work is not done, so no power is involved. So power is this, and work is not done, so 0 Newton is gonna be the answer. An 18-kilogram object has an initial kinetic energy of 36 joules. How far will the object move against a net resisting force of 9 Newton? So we can find the kinetic energy, and the force is gonna be 9 Newton. So the distance is gonna be 4 meters. The distance the object moves against a net resisting force of 9 Newton is gonna be 4 meters. A person with a weight of 340 Newton runs up a flight of stairs to a height of 4 meters in 8 seconds. The power required for the activity is so the weight is gonna be 340 Newton. So the power is gonna be this, and this is same with this. So the power required for the activity is going to be 170 watts. A cart is pulled at constant speed to the top of an inclined plane. If the mass of the cart is 4 kg and the height to which the cart is lifted is 0.52 meter, what's the potential energy of the cart at the top of the inclined plane? So the mass is gonna be 4 kilogram. And we are going to find the potential energy. So the potential energy of the cart at the top of the inclined plane is going to be 20.8 joules. The graph shows the acceleration of a particle. At t is 0, the speed of the particle is 1 meter per second. What's the speed of the particle at t is 5? The acceleration is constant from t is 0 to t is 2. This is constant. And again, from t is 2 to t is 5. This is constant. So we'll use this equation. So we are going to find this part, the velocity of this part and this part. So the speed of the particle at time is 5 is gonna be 17 meters per second. A shopper in a hardware store pushes a cart 25 meters north up on aisles. She then moves 3 meters west before turning south and moving 30 meters. She moved 3 meters east in order to pay for her purchase. What's her displacement? So the displacement is not equal to the distance. And a chauffeur is go to the north 25 meters first, and then move to 12 meters secondly, and again the chauffeur moved toward 30 meters, and she moved toward east 12 meters. So this is our starting point and this is our ending point. So displacement is not equal displacement. So displacement is not equal the distance. Distance is the sum of the lengths a person moved. On the other hand, displacement is the length from the starting point to the ending point. We can find the distance. It's gonna be the sum of this all distance. So we can find the distance is 79 meters, and we can find displacement by doing this, and the 3 meter minus 25 meter. This is because this is our starting point and this is our ending point. So the chauffeur's displacement is gonna be 5 meters to south.